Hello, this is Kwang Hak. For this cell shading assignment, our team implemented two outlines with silhouette detection. We modified the outline rendering to detect silhouettes dynamically. Instead of rendering back faces, implemented a technique that renders outlines only, where the angle between the normal and the camera view direction exceeds the threshold. So we get rid of the lines in the inner sphere, and for the borderline, give a dense surrounding line. Let me show the result we got from the code. This is the result we got. As you can see, compared to the original sphere, we keep the outline silhouette line and there's no inner lines. Okay, now let's go over the code. Let me go to the code we made changes. So this is the file path to run the lightweight Java game library components in my machines. And we add the library Java util map because we were using map. And we keep the most of the original code from the textbook. And this is well, our teammates made a changes. So this int normal index, the this code retrieved the index of normal vector associated with the specific vector vertex in a face triangle of the 3D models. And this face is an int array representing a face in the model. So I times 3 plus 2 calculates the position in the face array where the normal index for the ice vertex is sorted. And for this float normal, this line retrieves the actual normal vector corresponding to the normal index from the model normals list. And also there's more code for normal. And this sets the normal vector of the current vertex in OpenGL using GL normal 3F, which is used for lightning calculations. Now this is all the code from the textbook, and now let me explain the render outline function. The render outline function is responsible for rendering the silhouette outline of the 3D model. Therefore, by detecting the edges that form the boundary between front facing and back facing faces relative to the camera's position. So okay, so this is the width of the our like boundary lines, and we use map here. We create a map to store edges, and this is the faces that share each edge. And the key is a string representing edge, and the value is a list containing face indices and their orientations. And this code is building the edge to faces map. So loop through each faces of the model, check if the face is valid, and this this lines uh extracting vertices and calculating face normals. So retrieve the indices of the three vertices forming the current face. So gets the corresponding vertex coordinates from the model's vertex list here. Get the vertices. list, and mm, uh, yeah, this float edge 1 and 2 line. So this calculating face normal. So for the edges, compute the vectors for two edges of that triangle edge 1 and edge 2. And this is the cross product. Calculate the cross product of the two edges to get the normal vector of the face. And the normal vector is perpendicular to the plane of the face. And for the float lengths, this normalize the vector, this normalizing the normal vector. So compute the length magnitude and normalize the vector to make its length to equal to 1. And also normalization is crucial for like accurate lighting and silhouette detection. So that's why I wrote this code. And this is the camera view. So for the face center, compute the center of the face by averaging the coordinate of its vertices. And for the view vector, calculates the vector pointing from the face center to the camera. So this vector is used to determine whether the face is front facing or back facing. And and also there's a length. This normalizing the view vector. So normalize the view vector for accurate calculation of face orientation. And also float dot. This determine face orientation. So this dot product calculates the dot product between the normal vector and the view vector. If the dot product is positive, the face is front facing, and vice versa. If it's negative, the face is back facing. And for this orientation, store the face orientation as 1 for front facing and -1 for back facing. And here's string edges. Mm, for this, like string edges and this 4 string edges. What this do is registering edges and orientation. So construct the unique key for each edge. So add the face index and orientation to the edge to face map, and also allow tracking which faces share each edge. And now the last part of my code, it renders the silhouette edges now. So this for loop loops through all edges, and this this detect the silhouette edge. So an edge is a silhouette if it's shared by one front facing and one back face. And this is the rendering. Draw only like silhouettes edges as thick black lines slightly outside the model for a bold outline effect. Slightly outside the model. Since we made it like thicker, so it looks uh like surrounding the outline outline edges. and rest of it are the code from the textbook. And this is it for assignment 6. Thank you for listening.